Alright, in this video we're going to try to sort of mimic the range function. We're not going to make an iterable, we're going to make sort of the old school Python 2 version of the range function where it actually does return a list. In Python 3 we've been talking about the range function, and we know that the range function is an iterable. You can create an iterator out of it and access individual items one at a time using the next method or the next function in Python. So, but we're going to try to explore how we could create the range function ourselves in Python 3, but it's the old school version. It's the Python 2 version of range that actually returns the range list. Okay, so we're going to call this MyRange.py. All right, and I want to have a first, let's go ahead and add some niceties here. We add the hash bang. So in Atom, I can type env3 and it automatically adds the Python 3. If I hit tab afterwards, it adds this code snippet in there. So that's the hash bang that allows me to execute the program using the syntax .myRange instead of using Python 3 myRange. Right, so that's kind of a nice thing. It only works in Linux and Mac OS though, so be aware of that. The other thing you need to do is you need to change the mode, the access mode, so you need to make the file executable. So that is the chmod number 755. Those are 3 octal values. Alternatively, from the command line, I can say chmod plus x. So change mode plus add the executable bit for all 3 entities on MyRange. Right, and we say ls-al. Here's MyRange. Here are the 3 entities. This is the user, has read, write, execute permissions. This is the group, has read, write, execute permissions, and then this is the other. Right. So the group I actually don't want write permissions. So I think I accidentally added that here on change mode. Yeah, I want 755. There we go, and we see this changes. Now that removes the write permission, because these are 3 1s and 0s. 2 to the 3rd power is 8, so you can represent all the possibilities there with 1 octal number. Anyway, brief aside on permissions there. All right, back to range. So we know the range function. I'm gonna call this MyRange. It's going to generate some sort of list, right? And it's got a unique argument structure though, right? So we can say start, the stopping point, and then the step. So these are the 3 things you can pass to a range object or a range function call in Python. And but it's got an interesting signature here, because I can just pass in one thing, right? And just to show, if I define 3 parameters up here in my function signature, and I just pass in 1 like I do all the time, like in the normal range function. In the normal range function, I can just pass in 1 value. That's going to be fine. But in MyRange, if I have these 3 parameters defined, I'm just passing on the implementation right now, so it's effectively an empty function. If I try to do the same thing here, I'm going to get an issue. All right, so let's run MyRange. Okay, and so line 9 is the problem. So line 8 ran fine. We're used to seeing range there. Line 9 is the problem. We're missing 2 required positional arguments, stop and step. Okay, so how do I get around that in Python? I want to mimic the behavior of MyRange, and I want to mimic the way it does its arguments as well. Okay, so in Python there's a concept of collecting arguments. So you can use this syntax, the star syntax, and if you have any positional arguments, it's common to call it args, but this is really just a list. So any arguments you pass in are going to be collected into a list, right? And these are positional arguments, right? Not keyword arguments. Now you could also do something like args and quargs, right? And that will collect the keyword arguments into a dictionary. Okay, but we're just focused on the args, and I don't remember if it's 1 or 2 for quarks. All right, so here's my range, and I need that in the function signature, right? So args. So this is going to be a list. So any number of things that I pass in here, there's no set number. I could have lots of things, an empty list, you know, however many items I want, and this allows my function to take an indefinite number of arguments. So I can just print out this args list, and I can just reference args as if it was a list, because at this point it is a list containing all of the arguments that were passed in, and that's using the star syntax here. All right, so run MyRange. All right, and we look at this and we see something that looks sort of like a list, except what is this? We have parentheses here. All right, why do we have parentheses here? Well, this is because this is not actually a list. It is a collection just like a list, right? But there's a difference. This is what's called a tuple. So let's prove that. We're going to look at the type of this thing. All right, so this is a class tuple, as opposed to, you know, if we had a list of items, an empty list there. Okay, so this is an empty list, and it's a type list, right? This is a type tuple. What's the difference between a tuple and a list? Well, a tuple is, for all intents and purposes, the same as a list, except you cannot change values. All right, so let's go in interactive mode. If I have a list, let's make, we'll take a range, and we'll take 3 items. All right, we see we have a list of 3 items. Now let's make a tuple. I'm going to have a tuple of the same 3 items. All right, and let's look at the tuple. Okay, so notice the only difference really in the way it's displayed anyway is the characters used to delineate the beginning and the end, right? So we know this is a tuple because of the parentheses being used. But with the first one, I can mutate the object. So this is called mutability. I can mutate the object, and I can say the item at index 0, I want to change to something else entirely. I'm going to make this apple. And so that's allowed, and now my list contains apple in the first item. So it's mutatable, mutable, right? So with the tuple, if I try to access the item at index 0, that's fine, the value is 0. I can access item just the same. I can take slices. I can go from 1 to 3, right? And that gives me a different tuple. I can do all the things that I can do with the list. I can negative index, right? But what if I try to change the value? Tuple object does not support item assignment, right? It is immutable. You cannot mutate it. So mutability, mutable and immutable are important terms to remember. Okay, so a list is mutable, a tuple is not. Why is this beneficial? So one way to think about why this might be beneficial is if you think about a large object or a large list that has a lot of information in it, in a large system, you know, you might be passing this data around to lots of different people, lots of different functions, and if anybody modifies this data, it could affect everyone else, right? So if you pass them a tuple, you know that they can't possibly change it because it's not allowed, right? So this can, in certain situations, protect you against accidental modification of data, right? So a list and a tuple are exactly the same, except the list is mutable. The tuple is not. So the tuple is immutable. All right, so we can exit out of there. That's the idea of what this tuple is. But the nice thing is we have all of our arguments here using this star syntax. This collects all of the arguments into one list, and then we can access them. All right, so how do we want to do this? We want MyRange 5. Right? what are the three different scenarios for the range function, right? Well, let's real quick put pass back in here. Here are the three different scenarios, and I'll illustrate one with the range function, and then I'll mimic that with MyRange, right? So we've got the situation with one argument. We've got the situation with 2 arguments, right? In which case this will be the start and then the finish, right? Maybe we make that 6. And then here we've got 3 arguments, and this will be the increment. All right? So if we only have one item, there's an implied default value. The starting value is implied to be 0 to start with. And if we only have one argument passed into the range function, there's also an implied default step size. The step size is 1. Okay, so first of all, let's just set up our defaults, and we'll say if it's not explicitly in our list of arguments, then the start value is a 0. If it's not explicitly in our list of arguments, then the step value is 1. All right, and for each one of these different cases, we need to detect which situation we have. How can we detect which situation? Well, we can find out how many arguments were used by using the length function on this list. Right? So we can say if the length of our args is equal to 1, then the ending value is just, I guess this would be the stop value. Stop value is that item, right? So the item at index 0. So there's only one item in here, so we know we can access at least one item, right? Elif the length of args is equal to 2. Well, then we know we have this situation. We're provided the very first item in the argument list is going to be the starting point, and then the stopping point is going to be the next item. So that's going to be this start. We're going to overwrite what our default was here, right? And we're going to set that equal to args 0. And then the ending point is also being provided. So end is args 1. All right, and then else if the length of args equals 3, then we know we have to set all 3. And it's going to be the start value, the end value, and the increment. Okay, now something that's important, an important takeaway here, is that this is just a little syntactical trick in Python. I can set all of these at once. You see how I made 2 separate calls? I'm setting the variable start to the first item in the list, or in the tuple, and I'm setting the variable end, which I'm sorry, this should be stop, to the second item in the list, or tuple. Well, I can do all of that at once. I can say start, comma, stop, comma, step, and pass, set it equal to args. And then what this does is basically, this has 3 items in it, then each one of those items is stored in this variable. Okay, so we can see this really quick in Python 3 interactive mode. I can make, this works for tuples and lists, so if I want to make a tuple that has A, B, and C in it, right, this is my tuple. Let's see, we have a tuple there. I can say x comma y comma z, set that equal to my tuple, and we look at the value for x. It's A, y is B, and z is C. Okay, and you can do that again for lists. Li, we're going to make a list from that tuple. All right, we've got the list now of A, B, and C, and we can do the same thing. X comma y comma z equals the items in the list, and then x, y, z. All right, so this works with, anytime there's multiple items in either a list or a tuple, you can specify all of the variables for all of the items, and then one at a time they'll be assigned. So this is effectively the same. So on this second line, I'll add that in here. So this would be start, comma, stop is equal to args. Alright, so these two things are the same. This is just a fancier syntax. You can do it in one line. And so here I don't have to have 3 lines of code. It's just one. Alright, so that's the tuple assignment or list assignment, multiple assignment. One other thing with tuples real quick. Since we just have a parenthesis to define a tuple, you saw I defined the tuple up here just with the parentheses. How do I get a tuple with just one item in it? Because Python thinks that's just an expression, right? We use parentheses for calculating expressions, so Python thinks this is just the number 17. Well, if I want a tuple with the number 1 in it, after the entry I have to add a comma, right? And that's special syntax for just a tuple with one item. That's so Python knows the difference between a tuple and parentheses. Now with multiple items, Python can recognize there's a comma in there, so it's automatically a tuple. Python recognizes that syntax. But if there's not more than one item, then you have to add that comma explicitly, so Python sees that that is a tuple, right? And I can call the length of the tuple as well. So above I had the TU value, which is these items, right? So what's the length of TU? It should be 3, right? All right, so that's the last bit on tuples. Again, just remember that tuples are immutable. They cannot be mutated, whereas a list is mutable. It can be mutated. All right, so we're pretty close. We've started out this range function. Really, the hard part about it is what we've done. We get to start, stop, and step, right? But then after that, we actually have to construct our list. Okay, so how do we want to do that? Well, we start with an empty list. This is our results. I like to name collections. Make sure they have an S at the end because it's a collection. And then what do? Well, we can set an I value equal to start. We can say while I is less than stop. We can do our thing, which is basically adding an item, the I value, to our list. Right? So results dot append I. But then at the end of the loop, we need to add the step to I. So I plus equals step. Right? And so eventually, because we're adding step, I will become bigger than stop or equal to stop. And at that point, we won't add any more items and we'll break out of the loop, right? So results then should be filled, and we can just return results. All right, so let's print out these results. So I'm gonna post the arguments there at the top so we know what these are, and I need to print the results out for both of these. And here the arguments are 2, 6. Down here the arguments are 2, 6, and 2. And then we need to print these out as well. And close them all off. All right. Exit out of interactive mode and run MyRange again. Okay, yeah, so this is just returning the range object. We want to compare the lists to make sure they're right, so we have to do one more thing here and do list. Put list around each range function. That will make sure it's a list. And this will verify that we're getting the right output for at least these scenarios. Okay, and so we see that these two are indeed, each of these examples is the same. So this gets into test cases, and in a professional environment, this function that you've written here, you might use in another program, so you might want to import it. So you don't want your tests to run every time you import this file. So we'll use the common syntax: if underscore underscore name equals main. Okay. So this variable is a global variable built in by Python, and this is only main whenever you run the program directly from the command line. If you import the file, this will be the name of the file. So we only want our tests to run if we run the file directly. If I import this range function into another file, I don't want my tests to run because that would be slow and we get all this extra output that I don't necessarily want. Okay, so if I run the file directly, that's what this is basically saying. If running the file directly, run the tests, and we can have something like this. We'll have a format string in here, running tests for, and I'll put quotes around it, something like this. And so now when we run the file directly, it's going to run all of our tests, but it won't run the tests if we import the file. Right? And then this gets in, there's a whole lot of things you can do with testing. A lot of times in a real world environment, you're going to spend probably more time on the testing than you will on the actual writing of the function itself. So we've only got 3 test cases here, but we need to include, one of the things we haven't included here is negative tests. Right? So we might want to include negative values to see if those are working properly. All sorts of stuff that we need to test in here. So in order to do that, we want to run the tests, and we don't necessarily want to have to visually inspect to make sure they passed. Right? If I have 100 tests here, I don't want to have to visually inspect that each one of these 2 things are equal. Right? So my tests might be a little different. I might say tests passed, or just call it passed. Set that at 0, and then failed. And set that at 0, and then do something like this. This is the official range, and then this one is MyRange. And then I can say if range is equal to MyRange, then passed plus equals 1, else failed plus equals 1. And I can do that with all of these, right? And just swap in that's a 2 and a 6, 2 and a 6, 2 and a 6, and a 2. And then at the end, I could do something like print out how many results, how many passed and how many failed. So I could say print passed tests passed out of passed plus failed. Okay, and this is sort of getting closer to what you might do in a professional environment. Realistically, there's lots of frameworks that you would use rather than manually doing this sort of thing. But you see the idea here. I don't have to manually go through and look. I can just check programmatically if the things are equal. And so if I have 100 test cases here, then I can just run this, and we see 3 tests passed out of 3, right? And then I would only print this if it failed, right? So these headings, let's add that to the failed. That way I know which one failed. Right, so this style, you just run the tests, 3 out of 3 passed, you know you're good. Right? And you might have hundreds of tests. And again, like I said, in a professional environment, there are libraries that you would probably use for this instead of doing it manually. And a lot of the time you'll spend more time testing your individual functions or utilities than you will actually writing them. Okay, but that's important because if we change something here, we want to make sure our tests catch it, right? So if I change something and add some functionality, right, I want to make sure that it works. So let's say, for example, it's one of these simple things that I did here. Let's say I didn't want to use this method of setting variables equal, and I just wanted to manually do each one for some reason, but then I forgot to uncomment this one. Right? If I run this, now we should get an error, right? So stop wasn't assigned yet. So stop, right? And so what we want is these to show failures, right? But this one failed catastrophically, and we have an issue where we actually caused an exception, right? So the reality is we want something like this. We want to try to do this stuff. And then if there's an exception, then that's going to fail. So we can just throw an exception here, or I'm sorry, it's the syntax in Python is raise. So we're creating our own exception here. So if they aren't equal, we'll raise this exception, which means the except branch will run, and then we're printing out the value. Okay, so now if we do this with all of them, right? So we have. So you can see how quickly the testing becomes a little bit tedious if you aren't careful, right? And that's why there's libraries and stuff for this. So for the else statement, we'll do this. Right, and then this is 2, 6, and then here try, we indent all this code, and then we have the else statement and the exception, and this is 262. All right, so now we've still just got the 3 test cases, and in a real environment we might have hundreds. So we run that, and we see 2 tests out of 2 tests pass out of 3, right? So maybe we want to make that 2 out of passed plus failed, right? And maybe we want to get a percentage there too, right? So you could do the math there. That's a bit much. We don't need to go into all that. But see, 2 out of 3 tests pass. So that means I made a change to this code and something broke, right? So maybe I added a bunch of functionality, but it also broke something else. So this is incredibly important to professional development, that you have these tests to make sure code doesn't go out into production that doesn't work. So I need to fix that, and now we run the tests, and 3 out of 3 tests pass, so we're all good. All right, so that was just a brief segue into testing, but it's a very important part of coding professionally. All right. So anyway, this has been, there's some really good takeaways from this. We can collect arguments here in a function signature into a list, so that way we can have an indefinite number of arguments in our functions. So that was one really big takeaway. We talked about tuples. We can assign multiple values with a list or a tuple this way. Yeah, a lot of good stuff in this one. If we're running the file directly, we can use this syntax, and only the code will run if you run the file directly. So this will skip over the tests if I import the file. And then we've got some try except. So this is good testing. This is a good sort of basic framework for testing something, right? And like I said, there's a lot of testing frameworks you use professionally rather than doing this stuff yourself, but the idea is sound, right? Okay, so hopefully you learned something from this. I think that should do it for this video.